Hello students, today we are going to see something important. It is alcohol chemical properties part 2. Okay, in that session, reaction involving hydrogen halide, that is Lucas reagent, you are learning in practicals point also. So that point also I would like to mention here. And the second one, phosphorus trihalide and thionyl chloride. This, if it reacts with what it is, alcohol, what is the product? And dehydration, removal of water, dehydrogenation, it is removal of hydrogen, dehydration, removal of water, dehydroboration, that is oxidation method. I hope you remember all those points. In our last session we have gone through all these points. In our last session we have gone through alcohol reaction involving cleavage of OH bond, and now what we are going to see, cleavage of CO bond. Okay, in that first one, what it is, a reaction involving, that is reaction with hydrogen halide. Reaction with hydrogen halide, it is nothing, Lucas reagent. So what is Lucas reagent? Concentrated HCl and anhydrous zinc chloride. This is only Lucas reagent. So this reacts with alcohol. What is the product? How it is reacting? Which is reacting faster? Which is responding faster? That point we are going to see to that. So in the practical, what they are going to give in that organic compound, maybe primary, secondary, tertiary, any one kind of alcohol, they may give it in your hand. Okay, now how to identify? Take that 5 ml of given alcohol and you just add Lucas reagent. Suppose if it comes immediate response, that is tertiary, and after 5 minutes if it is responding, how it is responding, how it is, we can come to know immediate turbidity. It is not a clear solution, like it is like a turbidity. When you take that test tube, in that alcohol it is there, so you just put that drop by drop, what it is, Lucas reagent you put. So automatically you will get what it is. Immediate turbidity means you are getting what kind of alcohol? It's a tertiary. Suppose after 5 minutes, it's responding. That means after 5 minutes it's getting turbidity, means it is a secondary. Then after heating only, just after heating only it is responding. After heating only it's getting turbidity, means 100% it's a primary. Okay, so this is a what it is, practical point to be noted. Okay, hope you're clear with it. So in that primary reactivity series, for reactivity series, how to identify reactivity series? So in the tertiary it responds very faster, in then secondary it's reacting, and then primary. So this is the reactivity series. So tertiary you will get immediate turbidity, and secondary alcohol. So alcohol only we are talking. Secondary alcohol we are getting after 5 minutes. After 5 minutes, and primary alcohol after heating. After heating. Hope you're clear with it. This is general point to be noted for the practical session. Even in that, choose the correct answer also. Which alcohol responds faster? Like such kind of questions they may ask. Hope you're clear with it. Okay, the next one, alcohol reacts with phosphorus trichloride. You will get haloalkane only. Even we have learnt in haloalkane part also. And thionyl chloride. Alcohol reacts with thionyl chloride. You will get that haloalkane the same. Okay, now let us go for that CH3, CH2, OH combined with PCl3. You are getting what it is? CH3, CH2, Cl plus H3PO3, because this is phosphorus trichloride. This already we have gone through in our haloalkane alkane session, right? Okay, the second one, what it is, SOCl2, the same. Okay, we'll go for something CH3, CH3, here OH, here CH2, CH3, combined with SOCl2. By the by, what is the name of it? 2-methyl butane to all. 2-methyl butane to all. Can we write this? 2-methyl but to all. OL all, because this is OH. Okay, now what is the product? You will get the corresponding alcohol. What do you mean by corresponding alcohol? OH bond, it's replaced by Cl. That's all. So the same CH3, C here, what it is? CH3, here Cl, here CH2, here CH3. So that's what corresponding haloalkane you will receive. Here corresponding alcohol, wherever there is a OH, that can be replaced by what it is? Cl atom. Okay, then SOCl2 plus HCl. SOCl to SO and one more O. It is there no CO bond. That's what cleavage of CO. So this O will be removed. So that means here SO2 and HCl. One hydrogen will be removed from this hydrogen combined with chlorine atom. One chlorine has gone here, the other chlorine. It's coming over here. Hope you're clear with these two things. Now the next one, it is dehydration. Dehydration is nothing, removal of water. Okay, removal of water, that means alcohol reacts with dehydrating agents like what it is, sulfuric acid, anhydrous zinc chloride, alumina, H3PO4. So these are the dehydrating agents that reacts with alcohol. You are getting alkene. Alkene is the compound. So alcohol converted into alkene. Alkene converted into alcohols. Two important mechanism along with questions. It is there. So 3 mark question. Generally, it's very, very important. Come on, let us go for the now here CH3, CH, OH, CH3, right? Combined with H2SO4 in 443 Kelvin. So what you will get it here? Now I just put it here H2, here one hydrogen. Why? Just to rearrange it, you will get that product very easily. For that is the reason CH3, CH double bond CH2 plus H2O. Okay. Now here you will get water, and this one, this point partial double bond, you will get that. So you will get the double bond over here. CH3, CH, double bond CH2. Okay, now the same way here. CH3, CH2, CH2, CH2OH. I just put it in this way. Now here H2SO4, 443 Kelvin. Now what is the product? The same way, just a small rearrangement. So you will get the water product. So wherever there is OH in that, next to that carbon only, the water will be removed. That means that hydrogen will be removed. So what is the answer? You will get a product CH3, CH2, CH2, CH double bond CH2. Yes, CH. So automatically the bond will be going there. So you are getting what it is, butene. This is butyl alcohol. So butene here, isopropyl alcohol. Here you are getting what it is, propene. Hope you're clear with it. Okay, now the next one. One more point I would like to mention here. Now the next one, it is one cyclo compound we are going to see that. Usually long chain structure, it's very easy removal of water. But cyclohexane also something different. Here 1-methyl cyclohexanol. 1-methyl, 1-methyl cyclohexanol. All. Okay, now this is actually, don't think this is a benzene ring. Okay, cyclohexanol compound. Okay, now combined with H2SO4 at 443 Kelvin. What happened here also? Removal of water, H2O. Then what you will get the answer? You will get that double bond over here. CH3. So 1 methyl cyclohexene. 1 methyl cyclohexene, because removal of water from OH here, one hydrogen here. So here you will get the double bond. Then you will get what it is. 1 methyl cyclohexene. ENE compound, ENE. So alcohol, OL, alcohol converted into alkene, ENE. Okay. Now what we are going to see, it's a mechanism. It's very, very important. See, mechanism means you have to follow some steps. It's very, very easy. 3 steps only. First thing, protonation of alcohol. Protonation, how to get that protonation of alcohol. Then second one, carbocations formation. Third one, removal of proton. So these are the 3 steps to be noted. Now, come on, let us go for the mechanism we are going to see to that. This mechanism, how to convert, come on, how to convert alcohol into alkene. Good. Okay, so this is mechanism, what it is? Alcohol to alkene. So what are the steps to be noted here? We are going to see in a stepwise process of mechanism alcohol to alkene. In our last previous video, we have seen alkene to alcohol. Now alcohol to alkene. These both are very, very important. With the mechanism, 3-mark question. Number of times they asked. Okay. Now, protonation of alcohol, that is protonation of alcohol. The second one, formation of carbocation. Third one, removal of proton. It's so simple. The first step, how to get that protonation of alcohol. So here H2SO4 we have taken. No, this H2SO4 converts H plus HSO4 minus. This proton only, it's going to attach with alcohol, CH3 CH2 OH. So generally ethanol to ethene. Many times they asked question. Ethanol to ethene. Ethene to ethanol. Okay. Now ethanol to ethene combined with this H plus ion, that is proton. So you will get CH3 CH2 O. Here one hydrogen, here one hydrogen. So this is protonated alcohol, right? This is the protonated alcohol. First step got over. Now the second step. The second step, what happened? Protonated alcohol, it loses what it is, water molecule, and form carbocation. That's all. CH3 CH2 O, here hydrogen and here one hydrogen. It loses water molecule. So it loses water molecule means here you will get positive charge. Here what it is? CH3 CH2 carbocation formation plus water molecule. Right. Now this carbocation, third step, removal of proton. How to write that removal of proton? Here one hydrogen, here one hydrogen, here one hydrogen, CH3. Here C hydrogen and here hydrogen. Now what happened? Already water molecules removed. No, this is carbocation only. No, for you to understand easily, I have put it like this. So one hydrogen removed means this will be comes over here. Okay, so this hydrogen which is removed. So this hydrogen removed, that means a proton, removal of proton. So removed means naturally this bond comes over here. CH2 double bond CH2. Right? So CH2 double bond CH2. Ethene. Ethene. Right? Then you will get H plus ion, removal of proton. So these are the 3 important steps for 3-mark question. Alcohol to alkene. So number of times, like tug of war, alcohol to alkene, alkene to alcohol. Number of times they ask this question. Hope you're clear with this. Here I wanted to mention one important. In the second step, it's a rate determining step reaction. You know why it is a rate determining step reaction? Because it is a slow step reaction, right? Okay, now the stability of carbocation depends on what are the alcohols. It is tertiary, secondary and primary. Okay, now how to identify? Now as I wanted to mention here, reaction involving cleavage of CO bond. When that reaction involving CO bond comes means here tertiary, secondary, primary. When it reaction involves OH bond means primary, secondary, tertiary. So these are the difference between. Okay, so what are the difference between the cleavage, that order of that reactivity series means? So if it is OH bond comes means primary, secondary, tertiary, you will get go orderly. Now whereas here CO bond comes means tertiary, secondary, primary, that is a stability of carbocation formation. Hope you're clear with this. Here I wanted to mention one point. Reaction involving cleavage of CO bond. That means it's ready to take the reaction. Whereas phenol CO bond, it will not take place. Why? What is the reason? It does not undergo with this cleavage of CO bond. Why? Because partial double bond it is available. Partial double bond character. So it doesn't take place. That reaction will not occur in phenol. Only in alkyl group it will take place. Hope you're clear with it. Okay, now next point what we are going to see, it's phenol and its point. Thanks for watching.